Well, following on from the fascinating presentation of Jack, I'd like to talk about some practical approaches to sustainable nutrition and some clues to solutions in dealing with all this complexity. So Jack has already talked about the challenges of sustainably feeding the world's population, from population growth and urbanization, globalization, and climate change. But what I'd like to focus on more in this presentation is the aspect of food versus nutrition security. Now, food security has very much focused on calories out, but that is not really the most important thing. The most important thing is really adequate nutrition for every person on this planet to lead an active and healthy lifestyle. And in this context, we can explain it in terms of the spectrum of malnutrition, from undernutrition right through to overnutrition. As Jack explained, there's around 800 million to 1 billion people on this planet that are suffering from undernutrition with protein and energy deficiencies. 2.1 billion people that are either overweight or obese, and 2 billion people that are suffering from micronutrient deficiencies. Now, what does this actually mean? Well, sustainable nutrition can either be a virtuous circle or a vicious circle. But if we look at the positive side, the virtuous circle, improving nutrition will improve health. This will improve productivity, which will also have an impact on GDP and growth, leading to higher incomes, which will allow better nutrition. And, this is equally true for undernutrition as it is for overnutrition. People with obesity also have reduced productivity, etc. So within Nestlé, we've got a big program to further improve the quality of our product portfolio. And this, of course, involves what we call reducing the negatives, so reducing salt, fat, and sugar. And we have a huge program underway in this context. But it's also about increasing the positives. And one of the positives, as we've seen, there's 2 billion people suffering from micronutrient deficiencies. So we have already a very, very wide scope of products on the market that are fortified with iron, zinc, vitamin A, or iodine. And we're committed to reach 200 billion servings of fortified products by 2016. Well, we're well on the way. In 2013, we were at 160 billion. We're just in the process of consolidating last year's figures, but they're certainly already in excess of 180 billion. And many of these products reach right down to the bottom of the economic pyramid, like bouillon cubes fortified with iron. Bouillon cubes in many countries are bought 1 cube at a time. In this context also, we're working on biofortification, and our commitment is to introduce already biofortified products this year. And the products that we're working on particularly are maize, cassava, wheat, and some other crops like rice. One of the major challenges is establishing the supply chain. The varieties are available, they've been released in countries such as Nigeria, but establishing the supply chain, for example, of vitamin A enriched maize in Nigeria is a significant challenge. So this will allow us to have fortified products through biofortification, but it will also have a further benefit that the smallholder farmers growing these crops will improve their own nutrition by consuming part of their produce themselves. The second aspect has already been raised by John O'Brien in his question about animal proteins. Well, if you look at between animal feed and human food, from 100 kilos of animal feed only leads to 10 kilos of beef protein, 20 kilos of pork, and you can see the other numbers here. Now, in the future, if there's the increase of consumption of animal protein that is currently underway, the equation just won't work. Already there's a huge imbalance in animal feed, and we can see that, for example, exports of hay from the United States to China have increased by 2,900% in the last 5 years. So we have to find other solutions. So we've got a program underway looking very closely at plant proteins, both using the existing sources of proteins that are available today more efficiently, soy and pea, for example, looking at optimizing some emerging sources and then completely new novel sources of proteins in the future. So we're in the process of broadening our portfolio of solutions based on plant proteins. And this can lead to a lower environmental impact and still good sensorial properties, good taste, and commercially viable prices with the right nutrition. So with this background, how can we actually do this at Nestlé? How can we really integrate this in our product development? Well, we've developed and introduced, rolled out, through our research and development organisation, some tools that allow us to try to cut through this complexity and really develop products that are at the same time nutritionally sound with a lower environmental impact. So the first tool that we developed is a product eco-design tool called Ecodecks. And this is based on full life cycle assessment, but with a simplified interface. It takes into account the whole life cycle across the whole value chain, from agriculture through all the steps, right through to consumer use and end of life and waste. It allows us to calculate the effect in a series of relevant indicators, including greenhouse gas emissions, water consumption, non-renewable energy and minerals, land use, and the effect on ecosphere. And it's intended for non-expert use, giving quick results. So now this is in the hands of all our product developers. And I'll give you a first example of the use of this, and it comes back again to protein sources. Now here we calculated a comparison of beef meatballs, pork frankfurters, and 2 vegetarian alternatives that we have on our market, which are based on soy and wheat. And you can see on the left-hand side, in the spidergram, the red is the beef, the yellow is the pork, and the 2 in the middle, the blue and the green, are the vegetarian alternatives. So you can see a very significant decrease in all environmental impact factors. On the right-hand side, we can see bar charts of the effect of different parts of the chain, and the blue is ingredients, showing once again that it is the environmental impact of the ingredients themselves that have that play the biggest role overall. And clearly a massive improvement of environmental performance of the plant protein sources compared to the animal protein alternatives. So that's for calculating environmental impact. Now coming on to nutrition, we've developed something we call the nutrient balance concept, which is a novel way of looking about food products and diets, and it integrates the 30 essential nutrients that one needs for a healthy life, so vitamins, minerals, and proteins. A couple of examples. First of all, applying this to meals. And this is a typical meal in our canteen. This was steak, a small portion of French fries, and spinach. And on the right-hand side, you can see the results of the nutrient balance concept. So on the x-axis, basically, you have the goodies, which we call the qualifying index. And on the y-axis, you have the disqualifying index, so the baddies, if you like. And the number 88 in the middle is the percentage of the nutrients that you would need that you get from this meal. So this meal will provide 88% of the nutrients that you'd actually need. The calories for this meal were 700 calories. And then you can see the contribution from the different food groups. Well, spinach is off the map because it gives you a lot of nutrients for very few calories. You can see the French fries are over on the disqualifying side, and the pepper sauce does add a little bit. Then if we take a second example, and then talking about the environmental impact, on the left-hand side we have the impact of this meal in terms of the 5 impact areas that I described earlier. And again, you can see the huge importance of ingredients in the environmental impact for all areas. Then the second example was tortellini with salad. And you can see straight away that the overall nutritional value of this meal was much inferior to that of the previous one. And this only provides 32% of the actual nutrients required for 839 calories. And again, lettuce is over on the right-hand side, quite a lot of nutrients for very low calories. But in this case, the environmental impact of the meal is much, much lower than we saw in the case of the beef menu. And again, this is mainly due to the beef meat. So this illustrates how we can already start to put nutrition and sustainability together and start to understand some of the trade-offs and how we can start to optimize. And we can also apply this approach to complete diets. And the one I'd like to talk about today is taken from some work from the WWF, which is called their Live Well for Life. In this work, they looked at average diets in France, Spain, and Sweden, and then proposed a modified diet, and their aim was to reduce greenhouse gases by 25%. So we took their recommendations and recalculated them using Ecodecks and using the nutrient balance concept. Now this shows the current consumption in France, the split in terms of the different food groups, and the numbers there are actually the weights per day. And this is the Live Well recommendation with their aim to reduce greenhouse gases by 25%. And so you can see this is an evolution in what is eaten, but it's not a radical change because we have to be realistic. People are not going to radically change their diets. It needs to be an evolution. Now these recommendations gave roughly the same number of calories, and this is intended for an adult woman. And the cost was very similar, in fact slightly lower than that of the average French diet. Now looking at the food, this is some pictures which correspond to the consumption of 1 month. And you can see there's not such a huge difference. There is, here we can see, right on the right-hand upper side, you can see quite a substantial bowl of lentils. There is certainly more pulses and products of that kind, more lean meat. Fruit and vegetables are very similar. So overall, the Live Well recommendation gave an increase in grains, legumes, and potatoes, a small increase in dairy, and decrease in sweet products, animal protein, and mixed dishes, and a small increase in fruit, vegetables, and nuts. So what does this mean actually in terms of nutrition? Well, this is the calculating out that using the nutrient balance concept. So the current consumption in France gave 76% of the nutrients, and the Live Well recommendation was actually 87%, so an increase in the nutritional value. And you can see in the more detail in this graph, the items that were removed, those were increased, and those were decreased. Then if we look at the undersupply, in the normal diet there was a certain undersupply in all these nutrients, including the vitamins, and you can see here iron, potassium, magnesium, etc. And the Live Well diet actually had a lower number of these missing nutrients. So it was overall a better diet. Now, coming to the environmental impact using Ecodecks. So in terms of our 5 areas, greenhouse gas emissions, freshwater consumption, non-renewable minerals and fuels, and ecosystems qualities, these were all decreased between 11 to 20%. We could not confirm the 25% calculated by WWF, but we found 16%. It was in the same ballpark in terms of greenhouse gas emissions. Land use was about the same, and this is not surprising because there was not such a big decrease in meat and in dairy, but overall a lower environmental impact. So it really demonstrates that you can start to find the right compromises between environmental impact and nutrition, and even have win-win solutions. I haven't got time to talk about it today, but I just want to mention that food waste is extremely important in the context of sustainable nutrition. But I know Richard is going to be talking about that. And we're in the process of testing the new methodology of the World Resource Institute by mapping out the dairy supply chain in Pakistan. So we'll be presenting some of the results of that work in due course. And in conclusion, practical approaches to sustainable nutrition, what does it really mean? It's about knowledge in agriculture, in nutrition and health, and in environment. It's about the right tools, crop models to predict what's going to happen in the future under various scenarios. It's about nutrient profiling systems like the nutrient balance concept that I've described. And it's about eco-design software. And all this leading to better products. In the top right-hand side, we've got some new vegetarian burgers that are extremely tasty and nutritious with a lower impact, as we've seen. Products that are fortified appropriately, like some of these fortified bouillon cubes, and others like the Nesvita, which contain whole grain and soya protein, along with some dairy protein. And we're delighted to be part of, since almost 2 years now, with the SimSans program that is really trying to bring all these together and has given us access to some of the crop models which we don't have available within Nestlé ourselves. So in conclusion, nutrition and sustainability must be considered together to provide food for balanced diets to sustain for future generations. And all this fits in our way of doing business, of creating shared value, not only for our shareholders, but for our farmers and the communities, for our employees, and for our suppliers. And thank you very much for your attention. I'd be happy to answer any questions.
Thank you for a very interesting talk. Have you modeled dietary supplements, nutrient-containing dietary supplements in any of your models?
Not specifically supplements. We've been modelling a whole series of diets. We've been looking at some of the best diets, like the DASH diet, the My Plate, and some of the worst diets as well in certain countries, but we haven't actually modelled supplements, but it's something we'll get to in the future, definitely.
Thank you very much. I'm curious of the role of food standards in this thinking. We actually had an interesting case this last year where a product, I think a mayonnaise type product, became the subject of a suit because by using, I think it was pea protein as the emulsifier rather than egg, it no longer met the standard for mayonnaise. And I know in Ecodecks, when Canada proposed work on modified standards to meet nutrient requirements, many countries were strongly opposed because they worried about diluting food standards. So I'm just wondering what role that plays in moving this agenda forward.
Yeah, no, it's an extremely important question, and of course we have to adapt this to the standards in any country, but these have to evolve. These have to evolve. I mean, if we're going to feed 9.6 billion people sustainably by 2050, the food standards have also got to evolve here. So.
I raised the question because the work in Codex did not go forward. The United States, Canada, several countries supported it, but the majority of countries said, don't mess with our food standards, even if it's for a nutritional objective. So that's why I put the question on the table.
You're quite right. Mm-hmm.
Thank you for a very interesting talk. I was interested if you could share a little bit more about what nutrient recommendations underscore your scoring system, and particularly if it takes into account different needs by different population groups.
Mm-hmm. Mm-hmm. Well, actually, the nutrient balance concept can be very easily adapted to different nutrient demands by changing the criteria. So the criteria I showed you for live well was for a healthy adult woman in France, but it can be adapted to other needs. We just need that data, base data available, and then you can do the calculations exactly the same way. And effectively, as our work goes on, we'll be looking at that more closely to develop products for people with special needs as well.